Okay. Today we'll see about the PISO and PIPO. Okay, what is this PISO and PIPO in shift registers? Uh, so PISO. PISO is a parallel in serial out. Parallel in serial out. Okay, parallel in serial out. Okay. So for this PISO, you have uh, you have parallel in serial out. So this is PISO. So the inputs are clock and reset, and next you have load, and you are loading the data parallelly, parallel underscore u. Okay, this is 4 bit, remaining all are 1 bit only, remaining all are 1 bit only, and next you have serial out, serial out. So this is 1 bit, this is 1 bit. Okay, there is a load data. So load equal to 1. What it will do? So that means it will load the data. Okay. So that means data, whatever the data, will be loaded into temp register. Okay. And when load equal to 0, shifting operation will be done. Shifting operation. Okay. So while we are discussing the mm, PISO, so there we used the multiplexers. No, we use the multiplexers. Okay, so multiplexers. So the logic behind this is first here suppose so first you are loading the data. So let us take the index 3, 2, 1, 0. Okay. So first you are loading 4 bit of data. So 4 bit of data. So all fours you are loading. So 1, 1, 1, 1. Okay. So you are loading the data. And after that, you need to shift the data. Okay. Suppose I am doing shift left. Shift left. Okay. Shift left. Shift left means here first this will go, and this will come here, and this will come here, and one will come here. Whatever the vacant position is there, that will be loaded with 0. Okay. This is first shift. Okay. And second shift, this will go, and this will shift here. One will shift here. 0 will shift here. Whatever the vacant position is there, that will be loaded with 0. Okay. This is second shift. Third shift, this one will go, one will be shifted, and 0 will be shifted left, and the 0 will be shifted left, and whatever the vacant position is there, that will be loaded with the 0. Okay, this is third shift. Fourth shift, if you take, one will go, and 0 will be shifted, and this 0 will be shifted, and this 0 will be shifted, and whatever the vacant position is there, that will be loaded with 0. Okay, from this you need to develop a logic. Every time what happening, that means 210 is there, no? So this 210 is shifting and coming here. See here. So 111 is coming. Okay. At next shift, 210. Okay. 210. That is 110 is coming over here. Okay. And next shift, this 210. 210. It is coming over here. Okay. So I can write from here temp, temp, that is equal to, in the shift operation, I need to do temp, temp 2 down to 0, comma, whatever the new position is there, that will be loaded with what? 0. Okay. So, comma 0. By using concatenation operator, I need to use temp equal to temp 2 down to 0, comma 0. Okay. So, I'm writing the program. So this is the logic behind PISO. Hope you understood. First loading operation will be done. Okay, 4 bits of data, you need to load 4 bit of data. After that, you need to do the shift operation. Okay, based on the index value, I'm making the logic for the shift operation, that is temp equal to temp 2 down to 0, comma 0. Okay, so I'm writing the program module, module, PISO. My module name is PISO. Mm, input, okay. Input clock reset, okay. Input clock reset, and input I'm using a vector 3 down to 0, parallel in, parallel underscore in, okay, parallel underscore in. And uh, next input load, okay. Output, output serial underscore out, okay. Serial underscore out, okay. I need to declare the input and output, okay. Next I need to declare the temporary register, reg 3 down to 0, temp, reg 3 down to 0, temp, okay. Always, at the rate, I'm using asynchronous active low reset, asynchronous active low reset, okay. So if it asynchronous active low reset, always at the rate passage of clock or negate of reset, passage of clock or negate of reset. If not of reset, if reset equal to 0, temp you need to initialize to floating binary 4 zeros, okay. Tempo floating binary 4 zeros, okay. And next, else, else if load, if load, okay. If load, so that means if load equal to 1, I need to load the 4 bit of data, no. So there is a load data. When load equal to data, you need to load the 4 bit of data into temp register. If load equal to 0, you need to do the shift operation. First load operation will be done, okay. You need to load the 4 bit of data into the temp register. So if load, that means load equal to 1, temp is non-blocking with parallel underscore in, okay. Else else if load equal to 0, temp non-blocking with I'm using concatenation operator, temp, okay. This logic I need to write. What is this? Temp 2 down to 0, okay. This one I need to write. One second. This one I need to write. This one, temp 2 down to 0 comma 0, okay. So temp to 2 down to 0 comma 0, okay. So I need to write temp 2 down to 0 comma 0, okay. End, okay. After end, I need to, so that means here in the shift operation, so after shifting, so what you are getting out, that is temp 3, no. There is nothing but temp 3, okay. Temp 3 I need to initialize to serial underscore out, okay. Serial underscore out, okay. After end, I'm use continuous assignment statement, assign serial underscore out equal to temp 3, temp 3, and end module, okay. So this is the code for the shift register. Hope you understood. Any doubts or queries? Shall I move forward for the SIPO?
Sir,
Yeah, yeah, tell me. Hello.
సార్ టెంప్ నాన్ బ్లాకింగ్ ఉంటుంది సార్.
Temp,
నాన్ బ్లాకింగ్
where you are asking? Where you are asking?
సార్ ఇంకా కొంచెం కిందకి వెళ్ళండి సార్ చెప్తా.
Mm-hmm.
టెంప్ నాన్ బ్లాకింగ్ అట్ ద ఫ్లవర్ బ్రాకెట్ టెంప్ 2 down to 0 ఉంది కదా సార్. అక్కడ
Yes,
మనం
yes.
జీరో ప్యారలల్ ప్యారలల్ ఎన్ని కాదు సార్ ఇచ్చుకుంటాం, మన టెస్ట్ బెంచ్ జీరోనే ఇచ్చుకుంటాం.
Text bench I will show you. Just here, this is the logic. Actually, first
అంటే మీరు ఆ రోజు
you are loading the 4-bit parallel data that is given to the temp, that load equal to 1. And after
ఓకే సార్.
load equal to 0, here I showed the logic now. Shifting operation, and whatever the vacant position is there, that will be loaded with 0. So every time this copy is shifted, 2 down to 0 copy is shifted. See here, 111, this is shifted. 110, this is shifted. 100, this is shifted. Every time 000, this copy is coming, and whatever the vacant position is there, that is occupied with 0. So from this I wrote, so see here I wrote, here. See here, temp equal to temp 2 down to 0, comma, temp 2 down to 0, comma 0. Okay, this is non-blocking only. Actually, this is non-blocking only. So when you are writing in behavioral modeling, this is non-blocking only. In the code also, I wrote in non-blocking only. No, temp,
ఎస్ సార్.
temp is non-blocking with temp 2 down to 0, comma 0, and after that, I am using continuous assignment statement. Serial out equal to temp 3. Is it fine? Hello. Shall I move forward? Waiting for your response.
ఓకే సార్.
Okay, okay, okay. So here I will open the code. Shift registers. We are discussing SIPO, no? Same code. Okay. Same code, whatever I discussed. Here you see same thing. So module SIPO, input clock, input reset, input D in, output 3 down to 0, D out. 1 second. This is SIPO, sorry. PISO, PISO, parallel and serial out. Okay. So input clock, input reset, input load, input 3 down to 0, D in output D out. I'm using one temp register. So in place of here, I'm using uh, mm, this value. Okay, shift register. Shift register equal to, here I can use D in also. Okay, here I can use D in, or by using concatenation operator also I can use the D3, D2, D1, D0 also I can use, or I can use the D in also. Okay, it will take. Okay, so always at the rate passage of clock and engage of reset begin. If not of reset, shift register equal to what? 4 tick binary for all zeros. Else if load shift register equal to 4-bit data I'm loading. Else shift register equal to shift register 2 down to 0, 1 tick binary 0, end assign D out equal to shift register 3, end. Okay. And next, coming to the test bench, uh, PISO, TB underscore PISO. So if you see this PISO, module TB underscore PISO, whatever the inputs are there, I need to declare with reg data type, reg clock, reg reset, reg road, reg 3 down to 0 D in, y D out. So I need to instantiate this PISO. So connection by name I instantiated. So whatever the variables outside the bracket or nothing but input and output variables of the design, and whatever the variables inside the bracket are nothing but input and output variables of the test bench. And you need to generate the clock, always hash 5 clock equal to not of clock, initial begin, clock equal to 0, reset equal to 0, load equal to 0, din equal to 4 tick byte. Initialize the signals. Okay. First I am making reset equal to 0, and after that deassert the reset for 10 nanosecond for 10 time minutes, and during 10 time minutes I am loading the parallel data. So 1111 load equal to 1. I am making load equal to 1. After that I am making load equal to 0. Observe the single signals for 50 time minutes. Okay, whether shifting operation is doing done means happening or not. I'm making load equal to 0 means what? Shift operation. Okay, so load equal to 0 means shift operation. Shift operation. Okay, when load equal to 1 means it will do load operation. Load operation. Okay, dollar finish end model. Okay, so here you need to execute this. So in order to execute this, this PISO, need to set as top module. Again, run simulation, run behavioral simulation, save. So go to the simulation, fit to page. See here. First, loading of data is happening. Okay, loading of data. You can consider this as a binary also, radix binary. Okay, first loading of data is happening. Okay, next during the this one again what happening d out. So here loading of data is happening during the passage of clock. Loading of data is happening. Okay, 4 bits of data are loaded. Okay, after that loading of data is happening in the D out register. After that, here shifting of operation is doing. Shifting means what? 4 bits of data will be shifted out. Okay, shifted out. Okay. Here I want to see the shift operation. Uh, Suppose 8 you take. Okay, save this and run the simulation. Yeah, fit to page. So shift operation is happening. First, this is nothing but load operation. Okay. During 4 clock cycles, load operation, loading the 4 bit of data. After that, here during four clock cycles, means a shifting operation is doing. Okay. So all are becoming 0 only. Okay. All are becoming 0. That is given, that is getting at uh, D out. Okay. Means shift register that you are getting at serial out, D out. Okay, D out. Okay, shifting and loading of data. One second. See here, shift register underscore 3 equal to what? D out, no? So shift register underscore 3, shift register underscore 3, that is temp register, that is not included. This is shift operation is happening at the D out. Is it fine? Do you understood the concept? Shall I move forward? Waiting for your response.
Okay, sir.
Okay, yeah, yeah. So if you understand the concept, the understanding the waveform is easy only. Okay, no need to worry about the waveform and this coding. Mainly, you need to understand the logic. Okay, how the loading operation is happening and how the shifting operation is happening. Okay, and next will come with the last one, PIPO. PIPO is easy only. Parallel load and parallel. So parallel in load and parallel in it means loading the data parallelly and shifting means taking out the data parallel out. Okay, that is simple only. So RTL code for PIPO. PIPO. Parallel in parallel out. Parallel in parallel out. So if you see the parallel in parallel out, so this is PIPO. PIPO. So first you identify the clock input signals. Okay. So what are the input signals? Clock and next reset. Okay. And parallel in parallel underscore in. This is 4 bit, and this is 1 bit, and this is also 1 bit. And next you have parallel out, parallel underscore out. So this is 4 bit. Okay, 4 bit. Okay, so that means loading the data parallelly and taking out the data parallelly. Okay, so these are the inputs. First, you need to identify the inputs and outputs. So that means there are three inputs are there: clock, reset. This is 1 bit. Parallel in is 4 bit, and parallel out is 4 bit. Okay, so I'm writing the code for this module. My module name are identifier PIPO. Okay, so you need to give the module name so that you need to identify that RTL code. Okay, so that give the module name as by seeing that code, you need to identify for which one or which module you are writing the RTL code. Okay, input, clock, reset. Okay, and mm, load. Okay, load is also there. Okay, mm, load is also there. One more load. Load input is also there. Okay, input reset, input load, and input. I'm using a vector 3 down to 0 parallel underscore in, parallel underscore in, output, output. Okay, output. I need to use range. Why? Because this one I'm using in behavioral modeling. I need to use range 3 down to 0 parallel out, parallel underscore out. Okay, so I declare the inputs and outputs, and next I need to use this procedural blocks. Always at the rate passage of clock, passage of clock, or negage of reset, negage of reset. If not of reset, if not of reset, okay. Parallel out, parallel underscore out is loaded with you are initializing the outputs of all the flip flops. Okay, else else okay, else if load, okay, load, so if load equal to 1, parallel out, parallel underscore out is non-blocking with parallel underscore in, parallel underscore in. And okay, here I need to write begin, begin, always begin. Okay, always begin. Here also I think so. Here always I did it. Here also I need to write begin. Okay, so multiple statements are there. You need to write between the begin and end. Okay, begin, end, and end module, end module. Okay, so that's parallel in data and parallel out data. Okay, parallel. So whatever the 4 bit of data is there, that will be loaded into parallel out. Okay, this is PIPO. So coming to the program, PIPO. One second. Yeah, PIPO. This is PIPO. Okay. Um, so here I'm initializing the inputs. Module PIPO, input clock, input reset, input 3 down to 0. Load is, I think load is not required. Output 3 down to 0 D out. So reg, this is like PIPO. Okay. So reg I initialized. Okay. So if you are not using reg means like that also you can write. Okay, like that also you can try. Here you need to use the intermediate register reg 3 down to reg 3 down to 0 reg underscore data. Always at the rate passage of clock or negage of reset begin. If not of reset, reg underscore data equal to word. Clear the content of all the registers. Else reg underscore data equal to what this inputs D3, D2, D1, D0 by using concatenation operator. End And after that, assign d out equal to what? Reg underscore data. So assign the 4 bits of data to d out, end module. Okay. And coming to the test bench. Okay. Test bench, first you need to initialize the inputs with reg data type, output with y data type, and next you need to instantiate your PIPO, unit and a test. Variables outside the bracket are nothing but design inputs and outputs. Variables inside the bracket are nothing but test bench inputs and outputs. Generate the clock and initialize the clock. Clock equal to 0, reset equal to 0, DIN equal to 4 tick binary 000. And you are asserting the reset. After that, you are deassetting the reset for how many time units? 10 time units. And you are applying the different parallel inputs. Okay, during the 10 time units, you are making 4 tick binary 1010. During 10 time units, you are giving DN equal to 4 tick binary 1100. During 10 time units, you are giving 4 tick binary 0111. Hash 20 dollar finish. So after 20 time minutes, you need to run for 20 time minutes. After 20 time minutes, dollar finish end module. Okay. So this one, I need to simulate. Just set a stop module, run simulation, run behavioral simulation. You can see the output. See here, fit to page. I can give the outputs in radix binary. See here. First, so first what happening? That means first when reset equal to 0, okay, when reset equal to 0, what happening? The output means you are initializing the content of all the registers with 0 only. Okay. When reset is going from where to where, reset mode to functional mode. Okay. So immediately it will not happen. It will be synchronous with the clock. Okay, it will be synchronous with the clock. Okay. So during which clock edge? During this positive clock edge you need to get. Okay. During passage of clock you need to get 1 second. Passage of clock or negate of reset. Okay. Suppose if I give passage of clock, what happens? We'll see. Passage of clock. Uh, Fit to page. Means we are getting the parallel out data during the negate we are getting. Okay. During not during passage. During the negate of clock we are getting the parallel out data. Always celebrate. Save this. Run this. Fit to page. During negate only we are getting. 1 second. PIPO. One second. This negage only we are getting. During the negage, we are getting parallel out data. Okay, during negage of clock, we are getting parallel out data. But we during the, see means during this passage of clock, passage see here, during this passage of clock, the parallel out data is coming. So we can see during this passage of clock, we are getting the parallel out data. Okay, during this passage of clock. So parallel in and parallel out. So parallel you are taking out the taking the data and we are loading the data, and after that you are shifting, you are loading the data 4 bit of data at a time. Okay, so at a time, so this is loading of data. Okay, again here what happening during this passage of clock, you are getting it parallel out data. So during this passage of clock, you are getting parallel out data. So during negage of clock, loading is happening, and during this passage of clock, means coming to the D out is happening. See here, coming to the D out during the passage of clock, coming to the D out is happening. Okay, so this is nothing but parallel in, parallel out. Okay, is it fine? Do you understood the waveform? Shall I move forward? Hello, give response. Shall I move forward? Anyone?
Yes, sir. Move forward, sir.
Oh, okay, okay, okay. Thank you. And next coming to this. Universal shift register. Okay, universal shift register. So what it will do, like it will do all operations. Okay, shift left, shift means right shift, left shift, parallel in, parallel out. Okay, it will do. Okay, this is universal shift register. So universal shift register. So I need to initialize input clock reset underscore n. Okay, input 1 down to 0 select. Okay, I need to initialize the 2-bit data, that is select. Input 3 down to 0, this is parallel in data. And input s underscore left underscore d, this is serial left data in. Input s underscore right underscore d, this is if you want to serially give the data to from the right, so serial write data in. And this is the output range 3 down to 0 p out, parallel data out. And this is S left D out. So you are taking the data from the left, that is serial left data out, and serial S right data out. So you are taking the data out serially from the right. Okay. So always at the rate passage of clock. Okay. Passage of clock you can use means this also, or negage of reset, asynchronous reset. Okay. Negage of reset underscore n. Okay. Reset underscore n. If not of reset, so p out equal p underscore d out equal to what, 0. Okay. Else begin. I am using case statement. Okay. So case statement select is there now. What is that select? Two tick, so this is nothing but select equal to 2 bits now. So when select equal to 1, okay, 2 tick h, or you can use 2 tick binary also. Okay, 2 tick h1 hexadecimal. Okay, so you can use if it is binary, 2 tick binary 00. Okay, and 2 tick binary, 2 tick binary 0 1. Okay, like that also you can give. And here 2 tick binary 1 1, like that also, or h also you can give. H means what? Hexadecimal. Okay, hexadecimal. Okay, so 2 tick h 1, p out equal to what? So based on that logic only, right shift means what? S underscore right underscore d in, p out d out 3 down to 3 down to 1. Okay, and left shift means so when select equal to 2, p underscore d out, p underscore d out to 2 underscore, so d out to 2 down to 0, s underscore left underscore d in. Okay, so we already discussed the logic for left shift and right shift. Okay, if you understand the logic, you can understand this one. and parallel in parallel out. So what is parallel in parallel out? So 2 tick H3, then whatever the data present in the 4 bit of data parallel in there, that is coming to the P underscore D out. Okay, default P underscore D out equal to P underscore D out. Do nothing. Do nothing. Okay, case statement. Okay, so case statement, end case, end. Okay, this begin is there. No, this begin I need to end, and next this begin is there. No, this begin I need to end. Okay, after that, at last I need to use here I declared s underscore left d out and s underscore right d out with wide data type. No, so I'm using a continuous after the behavioral modeling. I'm using a continuous assignment statement. Assign s underscore left underscore d out equal to what? P underscore d out 0. Assign s underscore right d out equal to p under, that is coming to the uh, output. Okay, for the left shift d out of 0 is coming out, and for right shift d out of 3 is coming d out. Okay, end module. Okay, and coming to the test bench. So this is the test bench. So whatever the reg variables means inputs are there, you need to declare with reg variables. These are the inputs. Clock reset underscore n, select p underscore d in, and s left shift underscore d in, s right shift underscore d in, and whatever the outputs you need to declare with y data type, and parallel d out. Parallel. So this is p underscore d out, left shift d out, and right shift right d out. So I need to instantiate. So universal. So my design name is a universal underscore shift underscore register. My instance name user. So I'm instantiating connection by position with order list. Okay, clock comma reset underscore n. So how you declared the inputs in the design, that same thing you need to use. Okay. Again, always hash to clock equal to not of clock. Initial begin. I need to any dollar monitor means any change in the variables it will display. Okay, first I'm making clock equal to 0, reset underscore n equal to 0, and after 3 time units making so this is assetting the reset. I'm applying the reset, and after 3 time units I'm making deassetting the reset, and p underscore d in I'm giving 1101, and s underscore d in equal to 1 I'm giving, s underscore right shift d in equal to 0 I'm giving, and select equal to 2 tick h3 I'm giving. So that is parallel out. No, h3 is nothing but parallel out, and h1 is in the code we already seen. H1 is nothing but left shift. No, right shift. H1 is nothing but right shift. H2 is left shift. Okay, so H1 I am giving. H1 means left shift. Again I am giving D in equal to 0 and parallel out. Okay, again H2. H2 means left shift. Okay, uh, and H0 is do nothing and dollar finish and end. Okay, this is not required when you are using in the EDA playground. This is required. Okay, and if I want to execute this, just set as top module, universal shift register, run simulation, run behavioral simulation, save simulation. One second, run behavioral simulation. Yeah. So if you see in the TCL console, here you are getting these are the outputs depending on my operation test bench. So here, if you see the fit to page, okay. Here, what happening? See the test bench and analyze the output. Okay. See the test bench. First, what I am giving D in equal to 1101 and S equal to 1 and S D in equal to 0 I am giving, and select equal to 2 tick H3. 2 tick H3 means what? 2 tick H3 means parallel line, parallel out, no? So parallel out operation should be done. Okay, parallel out. So parallel out, select equal to 3. So here, whatever the D in is there. Okay. Uh, so binary. So binary. So here parallel in and parallel out. Okay, binary P in equal to 1101 I given, no. So give it to binary. See, 1101 I got. Okay. So next select equal to what I am giving. Select equal to 1 I am giving. See the code. Select equal to 1 means what? Right shift. Okay. First load the data. First loading of data is happening. Okay. After the shifting of data is happening. Okay. So that is select equal to 1. Here right shift is happening. That means first 1101 is there. No? Right shift means what? 0110. Next 0011. Next 0001. Next 0000. Okay. Right shift is over. And next, after select equal to 3, select equal to 3 means what? Parallel in, parallel out. Okay, PIPO. PIPO means what? Here, whatever the data is there, that will be coming to the D out. Okay, coming to the D out. After that, you are making select equal to what? Select equal to 2. Select equal to 2 means what? Select equal to 2 means left shift. Select equal to 2 is left shift. Okay, so my data is double one, 01. No? So left shift means 0011, no? 0011 and 111 means whatever you given left shift data equal to what? 1, no? Left shift data equal to 1. So left shift data underscore d in equal to what? 1. So whatever the vacant position is there, that will be loaded with what? 1 only. So that means first left shift, it becomes 0. This 1 will go, 0, triple 1 will get. Okay. After next shift, what happens? 1111 will get. Okay. If selection equal to 0, do nothing. Okay. D in equal to D out you are getting. Do nothing. So this is nothing but universal shift register. Okay, so it will do left shift, right shift, and PIPO also, parallel in, parallel out data. It will do. Okay, so based on the test bench, you need to identify. You need to understand the simulation, how the simulation is happening, and all those things. Okay.